Good morning, students. I hope you all are doing well. I, Rohini Jasrotia, welcome you all to my online class. Students, today in this class, I am going to teach you chapter 2 from your textbook, and the title of topic is polynomials. So students, before starting the topic, we have to recapitulate some basic terms so that you can understand the topic in a better way. Let us come to our recapitulation part and discuss our first definition. Now, we have to discuss about what a constant is. Now, these are the symbols having fixed numerical value. Let us see the examples here. 5, -1, pi. These are some examples of constants. Now, I will explain you how they will act as a constant, because when someone will ask you to write 5, you can't write any other number in place of 5, because 5 has its own fixed value and other numbers have their own fixed values. Students, one more example. If I will talk about pi have two universally accepted values, that is 22/7 or 3.14. You can't use any other value instead of pi. So these are some of the examples of constants. Now let us move to our next definition, that is variables. Now these are the symbols having different value in different situations or cases. Now, what does it mean that different value in different situations or cases? Students, let us understand this with the help of some examples. You can see the example here. In first example, I have written x minus 5 is equal to 0, and if I have to find out the value of x, I will get x is equal to 5. Now, in the second case, here x minus 3 is equal to 4, and if I have to find out the value of x, I will get x is equal to 7. So students, you can see that here the variable x is acquiring different values in different situations. Now the question arises here, how we denote these variables? We denote these variables with the small English alphabets, as I have given here, like X, Y, Z, A, B, C, whatever your choice is, you can use that particular alphabet for denoting the variable. Now let us move to our third definition, and that is algebraic expression. The combination of constants and variables connected by operators like plus, minus, multiply, divide are called algebraic expressions. Students, I have given two examples here, like x square plus 3x and y raised to power minus 3 plus x. You can also write so many examples in which there is a combination of constants and variables. Now students, let us come to our topic. And the topic is polynomials. Let us see what does a polynomial mean and what does it refer to. The word polynomial has been derived from two words. Poly means many and nomial means terms in this case. So, it says an algebraic expression with many terms. Students, what you have to remember about polynomial is that it is an algebraic expression with many terms. Now, it has some more properties also. Let us see. We can also write a polynomial in one variable as an algebraic expression of this form. Students, you are looking here that p of x is equal to a n x raised to power n plus a n minus 1 x raised to power n minus 1 plus so on to a2 x raised to power 2 plus a1 x plus a0. Now here a0, a1, a2, so on to an or constants, and an can never be 0. Now, a0, a1, a2, so on to an are respectively the coefficients of what? x0, x power 1, x power 2, and so on to x power n. And here n is called the degree of polynomial. Here n is called the degree of polynomial. In other words, we can say that an algebraic expression with non-integral power of variable. Now, students, just focus on this concept. What it is saying that it is an algebraic expression, right? You know about algebraic expression, what an algebraic expression is, right? After that, its main concept regarding the polynomials is that it has non-negative integral power of variable. What? It has non-negative integral power of variable. With non-negative integers, I mean the digits or numbers that are starting from 0, 1, 2, and so on to like this. Students, for understanding this concept clearly, let us see these two examples. Firstly, by observing this example, tell me how many variables are there. I am sure that you will see two variables there. One is x and one is y, right? When I am talking about the power of these variables, you can see that there is no number on the power of x. It means the power of x is 1. Now here the power of y is 2 and the power of x is again 1 and the power of y is 3 here. So students, you can see that here the power of variables are non-negative like 0, 1, 2. Now where the power of variable is 0 here in this case. When minus 3, we can also write it as minus 3x power 0. So students, you can see that this example is of polynomials. Now let us see here. In this example, you can see that again you can see that there are two variables, that is x and y, but here the power of y is minus 2, so we can't say that it is an polynomial. Again here the x is in the denominator, so it means the power of x is minus 1, so again it can't be a polynomial. So the main difference between an algebraic expression or any polynomial is that the polynomial is an algebraic expression, but it has non-negative integral power. Students, let us see one more example here. Here in this example, you are observing that here x square plus 2x is the example of our polynomial. Now, the question arises here, what you are observing in this example? The first observation is that it has two terms. How many terms are there? Two terms. Now, how many variable are there in this example? So x is the variable and there is only one variable in this example. Now here 1 is multiplied with x square, so 1 is the coefficient of x square, and 2 is multiplied with x, so 2 is the coefficient of x. Now the next observation that we are seeing here is 2 is the degree of polynomial. Students, let us move to some more examples. Like, you can give any other example in case of polynomials, but you have to remember only one thing, that the power of variable must be a non-negative integer. Like if I am talking about x raised to power 3 plus x raised to power minus 4. So students, it can't be a polynomial because its power is negative. If I am talking about one more polynomial, that is x plus y, yes students, this is also an algebraic expression, but it has two variables in this case. But in this chapter, we have to study only one variable. That is, our main concern is on polynomial of one variable only, but there can be polynomial of two variables or three variables. Now, some more examples of polynomials are like t plus root 2t. Let me write it again clearly. T plus 2 root 2 and t. Now, the students, you can see that here t is your power of t is 1 and again the power of t is 1. So, yes, it can be a polynomial. Now, if I am writing t plus root 2 upon t, it can't be a polynomial. Why? Because its value is t raised to power minus 1. If I am saying x plus root y, again it can't be a polynomial because power of y is 1 by 2. So students, before understanding about the polynomials, you have to consider all these concepts. Since in previous slides you have seen that we have discussed about the coefficient and we have also discussed about the degree. Now the question arises here, what a coefficient is, or what do you understand by coefficient of a variable? Students, let us see what it means. A number used to multiply a variable is known as coefficient of variable. Let us understand this with the help of an example, 6z. 6z means 6 times z, where z is a variable and 6 is a coefficient. Students, you can see that a coefficient is a number or any other thing that is multiplied with a variable. Variable with no number have a coefficient of 1. In case you see that if there is a variable and it doesn't have any number with it, so it means that 1 is the coefficient of that variable. Sometimes a letter stands in for the number. Example, ax plus b. If you will see ax plus b, you will get confused that there is no number with variable. So we can say that here a is coefficient of x and b is also a constant, right? So a is coefficient of x. Why? Because a is multiplied with x, and sometimes letter also act as a coefficient. Now let us move to our next concept, that is degree of polynomial. So students, you can see that the highest power of the variable in a polynomial is known as degree. So it is one of the important concept in this chapter. What is the degree of a polynomial? So you just have to remember that it is the highest power of variable in a polynomial. What? It is the highest power of variable in a polynomial. Let us see some examples. Students, here 6x raised to power 8, so degree of polynomial is 8. Now here this is one term, and x raised to power 6, y raised to power 3 and z raised to power 1. Obviously it is a polynomial in 3 variables, and degree is equal to 6 plus 3 plus 1 is equal to 10. Again in this, here there are so many where 3 variables are there and there are 3 terms also. So here the power of x is 5, here the combined power is 10, and here the combined power is 7 plus 4, that is 11. So students, the degree of this polynomial will be 11. So I hope the concept of degree is clear to you, that the degree of polynomial is the highest power of variable in a polynomial. Now types of polynomial on the basis of terms. Students, you can see that there are 3 types of polynomials on the basis of terms. First is monomial, second is binomial, and third is trinomial. Polynomials having one term are known as monomials, polynomial having 2 terms are known as binomials, and polynomial having 3 terms are known as trinomials. For 1 it is mono, for 2 it is bi, and for 3 it is tri. So Types of polynomials on the basis of terms are 3, and these are types of polynomials on the basis of degree. The first type of polynomials on the basis of degree is constant polynomial. Here the constant polynomial has degree 0. Here some examples are given like 2, 3, 5, etc. The polynomial of degree 1 is linear polynomial, polynomial of degree 2 is quadratic polynomial, and polynomial of degree 3 is cubic polynomial. One more thing is there, 0 is also a polynomial and it is known as zero polynomial. The degree of zero polynomial is not defined. Again, the question arises here, why the degree of zero polynomial is not defined? Let us see. If I am writing 0 here, so 0 raised to into x power 0 is 0. 0 into x power 1 is again 0. So students, you can see that with any variable's power I will multiply 0, I will always get 0. That is why the degree of 0 polynomial is not defined. Let us move to our next slide that has given some few examples. Here you can see that polynomial 6, its degree is 0, it's constant polynomial and it's monomial. So as the case, like this is, its degree is 2, it is quadratic polynomial and it has 3 terms, that is why it is trinomial. Now let us move to some exercise question. Let us see what the first question is saying. Which of the following expressions are polynomial in one variable and which are not? State reasons for your answer. Students, by looking at the first part, you can see that this is a polynomial in variable x. In the second part, y square plus root 2, yes, this expression is a polynomial in variable y. In the third part, 3 root t plus t root 2. Here students, you can see that 3 root t is equal to 3 t raised to power 1 by 2. You know that it is not a non-negative integer, that's why this expression is not a polynomial. Rest of the parts you will do by your. Let us see question number 2. In question number 2, you have to show the coefficient of x square. In first part, the coefficient of x square is 1. In second part, the coefficient of x square is minus 1. In third part, the coefficient of x square is pi by 2. And in fourth part, root 2x minus 1. Students, here x square is not present, but you can write it as 0 multiply x square. So the coefficient of x square is 0 here. In question number 3, you have to give an example of a binomial whose degree is 35, and again you have to give an example of a monomial whose degree is 100. When I'm talking about binomial, it must comes in your mind that binomial is a polynomial of 2 terms and you have to mention degree 35. So this is an example. And monomial is a polynomial of 1 term, and this is an example. So concept behind this question is that what I have explained you, that mono, bi and tri means 1, 2 and 3 respectively. This is the concept that I have shown to you behind this question. Okay, now let us move to question number 4. Question number 4, you have to tell the degree of polynomial. Okay, so in first expression you can see that this is a polynomial in variable x and the highest power is 3, so degree is 3. In the second part, firstly balance this polynomial and after that converting it into this, you can see that the variable is y here and the degree of polynomial must be 2. In the third part, variable is t here and the degree of polynomial is 5, and the degree of polynomial is the degree of polynomial is 1 here, and in the last part here 3 is the only polynomial, and so the degree of variable must be 0 as it is a constant polynomial and the degree of constant polynomial is always 0. Now let us move to question number 5. In this question number 5, you have to identify which type of polynomial is this on the basis of degree, right? In the first part, as it has degree 2, so it must be a quadratic polynomial. It has degree 3, so it must be a cubic polynomial, and same is the case with rest of the parts. Now let us see. R square is a quadratic polynomial as its degree is 2. 7x cube must be a cubic polynomial as its degree. Students, I welcome you all to my next video. In this video, I am going to teach you zeros of polynomial, which is the next subtopic of your chapter number 2, that is polynomials. So let us see what are zeros of polynomial. A real number a is 0 of polynomial p of x if p of a is equal to 0. Now students, listen it carefully. What I am saying, it is very easy concept if you understand it properly. Here you know that you will denote your polynomial with p of x or any other variable in which your polynomial is present. So I am saying that or zeros of polynomials are those real numbers which make your polynomial 0. Okay, so I will tell you this with the help of an example. Let us move to our next slide. Now students, just have a look at example number 1 and see what is written there. Find the zeros of the polynomial p of x is equal to x plus 2. What you have to do? You have to find out the zeros of the polynomial p of x is equal to x plus 2. Now students, we will follow a particular algorithm to solve this question, or I can say that to find out the zeros of polynomials. It is very simple concept and very simple algorithm, and you can easily solve these questions, but just you have to listen or understand one question or one example properly. So let us come to our solution. In the step 1, what I have done, I have kept px is equal to x plus 2 as such. Now in the step 2, what I have done, I have kept my polynomial, or I have equated my polynomial with 0. Okay, I have equated my polynomial with 0. After that, you know the value of px is equal to x plus 2. That is why I have written x plus 2 is equal to 0 here. Now after transposing plus 2 here from LHS to RHS, I will get x is equal to minus 2. So students, at last I have got the value of x is equal to minus 2. Now I have find out the value of x is equal to minus 2, and this is the zero of polynomial. So students, listen it carefully. Let me write down the polynomial x plus 2. Now which value of x you will put so that the answer of your polynomial will be 0? Obviously it will be minus 2 plus 2, and that will be equal to 0. So students, it is very simple that if you will put minus 2 instead of x, you will get 0 here. So 0 of polynomial is that value in which or which makes your polynomial equal to 0. Students, you can see that in last I have written a note. From this example, you have observed that there is only one zero of linear polynomial, right? What you have observed? How many zeros we got? We got only one zero, right? Let us see our example number 2. Find the zeros of polynomial Rx is equal to x square plus 4x plus 4. So students, we will follow the same algorithm, and in the step 1, what we are going to do? We will just follow the same rule, and firstly we will write down Rx is equal to this, and after that we are going to equate our polynomial with 0. As we know, the value of Rx is equal to x square plus 4x plus 4, so we will write for x square plus 4x plus 4 here. Now in step 4, you know that as this is a 3 terms, so we will factorize it by using splitting the middle term, which you have read in your previous class. So we have to take two numbers so that their product is 4 and their sum is also 4, so we will take 2 and 2 here. Now after that, taking 2 and 2 common here, at last we will get x is equal to minus 2. So we are getting two zeros here, right? So in this example, you can observe that for quadric polynomials we are getting 2. Students, let us see our next slide. In next slide, firstly I have written a result. It and the result is saying that a polynomial of degree n has n zeros. Yes, it is right. So students, in general form you have to remember that whatever the degree of polynomial, the same number of zeros of that polynomial will be. I can say that degree of polynomial is equal to number of zeros of that polynomial. Okay, if the degree of polynomial is 2, zeros will be 2. If the degree is 3, zeros will be 3. Now let us see one more example of another type. In this example, what we are doing and what we have to do, let us see. Verify whether 2 and 0 are zeros of the polynomial. Now students, in the previous examples we have learned how to find zeros of polynomials. Now in this example we have to check whether these two numbers are zeros of polynomials or not. We will follow the same method, but let us see how we are going to do it. So let p of x, firstly we will let our polynomial as p of x, r of x, whatever your choice may be. After that we have to put x as these numbers. Like in case 1 I will put x as 2, and in case 2 I will put x as 0. Now when I have put p is equal to x is equal to 2, then I have got the answer as 0. Again when I put p is equal to x is equal to 0, then I got answer as 0. So yes, if I am putting the values 2 and 0, I am getting my polynomial as 0. So yes, 2 is also a 0 of polynomial and 0 is also a 0 of polynomial. Okay, I think you have understood this example. What I am saying, when we have to check whether these two numbers or any other numbers are the polynomials or are the zeros of polynomials, so at that time we will put that number in polynomial and check the answer. Now students, let us solve some exercise question and let us move to exercise 2.2. Find the value of polynomial 5x square x minus 4x square plus 3 at, here different values of x are given. You have to put it one by one and solve the answer. I have just done one for you and rest of the parts will be your homework. So let us see. Let p of x is equal to 5x minus 4x square plus 3. Now in the first part you have to put the value of x is equal to 0. So in this step we also put the value as 0. So p of 0 is equal to, in place of x you are going to write 0. So 5 0 into 4 raised to power 4 into 0 square plus 3. So p of 0 is equal to 0 minus 4 plus 3 and p of 0 is equal to 3. So same is the case with x is equal to minus 1. You have to put the value of x is equal to minus 1, and in the third part you have to put the value of x is equal to 2. These parts will be your homework. Now let us move to question number 2 and let us see what we have to do here. Question is saying that find p of 0, p of 1 and p of 2 for each of the following polynomials. Students, here I have taken two parts. First is your p of y is equal to y square minus y plus 1, and second is your this one. So for part 1 you have to solve 3 times. I mean that you have to put the values like 0, 1 and 2 in the first expression, and after that you have to put the value 0, 1, 2 in the second expression. Now let us see here. First expression is your p of y. Now I will put y is equal to 0 here. So when I am putting y is equal to 0, so what will happen? I will get 0 square minus 0 plus 1 and answer will be 1. Now in second case I have to put value of y is equal to 1. So after putting the value of y is equal to 1, again I will get 1. Now put the value of y is equal to 2, and after that what I will get? I will get p of 2 is equal to 3. Now in the same case, in the same type, you have to follow for part number 2. Like In this, firstly you have to put x is equal to 0, after that you have to put x is equal to 1, and at last you have to put x is equal to 2, and you have to find out the values. Now let us see question number 3. In question number 3, again verify whether the following are zeros of the polynomial indicated against them. So students, I think you remember example number 3, in which how we can verify the values that they are the polynomials, zeros of the polynomials are not. So let us see here. Now I am writing here p of x is equal to 5x minus pi, right? Now what we will do, we will put x is equal to 4 by 5, right? So now 5 into 4 by 5 minus pi, you will 5 and 5 will be cancelled, so answer is 4 minus pi. So students, you know that it is not equals to 0, so it is not 0 of, इसका 0 नहीं है ये px का, it is not 0 of, it is not 0. Okay, fine. Now let us see second part. In the second part again, p of x is equal to lx plus m. Okay, he put x is equal to minus m by l. So here L into minus m by L plus m, L and L will be cancelled. At last you will get minus m plus m, that will be your 0. So yes, it is a polynomial. Students, let us move to question number 4. In the question number 4, find the zeros of polynomials in each of the following cases. Let us see first part. Here what we are going to do, let us see p of x is equal to ax. You know very well how we are going to solve this question. After that, p of x is equal to 0, so a of x is equal to 0, so x is equal to 0 upon a, and x is equal to 0. This is the answer for first part. Now let us move to part 2. P of x is equal to cx plus d. Now p of x will be equal to 0, so cx plus d is equal to 0, so cx is equal to minus d, and x is equal to minus d upon c. This will be your answer. So students, practice rest of the parts at your home. If you will come across any problem, you can ask me in the doubt clearing session. Stay home, stay safe, and enjoy learning.